right. Wanted to show you an example from 8.2, which we didn't get to cover in class, which is the t-test for one sample mean. And this is a test about the body temperatures. Is the mean body temperature really 98.6 Fahrenheit, as we have always been told? Well, this is a sample of 106 body temperatures, and the sample mean is 98.2 with a standard deviation of 6.2 degrees Fahrenheit. Use a 0.05 significance level to test the common belief that the population mean is actually 98.6. This is a sample size of 106. It is a simple random sample, and since it's larger than 30, we don't need to test for normality. However, we can identify the null and the alternative hypothesis. Since we're testing the claim that the mean body temperature is 98.6, that is the null hypothesis, and it is also the claim. The alternative hypothesis is that the mean body temperature is different from 98.6, and so this is a two-tailed test. We've already been told to use a 0.05 alpha level, so we'll use that significance level. And we're testing a mean without knowing the population standard deviation, so we'll use a t-distribution. Now the t-stat and the p-value we're going to get from the calculator. So let me pull up my calculator and we'll try to replicate this. Okay, so here is our page of one sample t for mean on the Gale-Illich calculator that Ms. Illich created. We need to put in on this page our sample mean of 98.2. Remember, only type in the pink or orange boxes. Our standard deviation is 0.62. Our sample size is 106, and since our alpha level is 0.05, 1 minus 0.05 is 0.95. We'll put that in for our confidence level. And then down here we want to put in our null hypothesis that the mean equals 98.6. Alright, and so we can see here our t-stat of negative 6.64, rounded off, and this is a two-tailed test. Notice how small our p-value is, 0.000000001. It's basically 0. So basically we have a p-value of 0 here, and so we can make our decision. And then our p-value of 0.0 is definitely less than our alpha level. Therefore, we will reject the null hypothesis. Remember, the null hypothesis is our original claim. So we need to state our decision in terms of our original claim. There is sufficient evidence to reject the claim that the mean body temperature of adults is 98.6. And you can also notice on your calculator that you're given a confidence level. A confidence interval. And the 0.95 confidence level is fine for the confidence interval since this is a two-tailed test. We don't need to change that confidence level. But we have a confidence interval of a 98.1 to 98.3, and notice that 98.6 is nowhere in that confidence interval. Since we are 95% sure that our confidence interval contains the population proportion, the population mean, the confidence interval also supports our conclusion to reject 98.6, since 98.6 is not in the confidence interval. So, I hope this example helps you as you complete your homework and get ready for your test on Wednesday.